We have a classic exercise of Punnett squares. They all set up the same way. All that changes is the genotypes of the organism. So let's take a look at this one. It reads, a woman with long eyelashes is paired with a man that also has long eyelashes. The woman's genotype is this right here. She has two capital E's for eyelashes, and the man's genotype is this right here. He has one of each. And then a very important part of information is that long eyelashes are a dominant trait. So this means that this woman has long eyelashes, like it says right here, because she has two dominant alleles. And the man's genotype is different from the woman's, but he also has long eyelashes because this dominant allele got expressed, as they always do. So the way we start to approach this exercise is by quite literally making a Punnett square. So let's go ahead and do that. We start by making a square that looks kind of like this. Doesn't have to be perfect, but I'm using this software right here. It's gonna make a nice square. You divide it by half, then you divide it by the other half. Then you have 4 quadrants. These 4 quadrants, you're gonna fill them up. One side is gonna be mom, the other side is going to be dad. Doesn't matter which one, but it's very important that you use, I like to use the left and upper side. You can use the right and upper, you can use the right and down, you can use down and right. You can make any combinations of those, but you have to be two-dimensional. Okay, one in one dimension, the other one in the other dimension, following these lines in the middle. Again, this side is for mom, and this side is for dad. So let's take a look at the genotypes. It says right here that that's genotype. Let's start with mom. She's first. It says right here that she has this genotype right here. So let's go ahead and do that. She has one capital E for the first half, and the other allele goes in the lower half. And we're done with mom. Now, when it comes to dad, he has these two alleles right here. So you can go ahead and put that in the first half, and then the other allele in this case is a lowercase e. So we got dad's genotype on top and mom's genotype on the side. The way we fill this up is we always look to the left, we always look up. To the left and up for each quadrant right here. So let's go ahead and do that. When you look to the left, you have a capital E. And when you look up, you have another capital E. So this quadrant goes like this. When we go here, we look to the left and we have a capital E. And when we look up, we have, in this case, a lowercase e. In this right here, we have a capital E on the left side and a capital E on the upper side. Finally, we look here, we look to the left, we have the capital E, and we have the lowercase e. We are done with the Punnett square. As you can see, it's really easy. Now, you may want to understand how to interpret the square. The way I like to think about it is if this whole square was a $1 bill, then each quadrant would be a quarter. Okay, so each quadrant would be a quarter because they all represent 25% of the whole thing, just like the quarter represents 25% or 25 cents of the dollar. So with that said, you can answer questions, for example, like, let me show this right here. When they ask about, there they go, about what percentage of, let me write in here, what percentage of homozygous dominant would turn out from this offspring? What percentage of heterozygous would turn out, and then what percentage of homozygous recessive will turn out. Well, let's take a look. How many squares do you have that have two capital E's? I see two. 2/4 represent 50 cents. And percentage-wise, it's the same thing. But since we're talking about percentage, we're gonna put this percent right there at the end. When we talk about heterozygous, the same thing, right? We have two squares representing 2/4. That means you have 50 again. Okay, 50%. Now, how many of these squares have two lowercase e? None of them. That would mean you have 0.0 that have lowercase e. This is how you predict the genotype of the offspring. There's a 50% chance they're gonna be like this. They're gonna be a 50% chance of them having this genotype. When it comes to the phenotype, though, the only way they're gonna have short eyelashes is if they have this kind of genotype, because long eyelashes are dominant. So in other words, there is a 0% chance that these kids will have it's a probability, there you go, of having short eyelashes, and 100% chance, because 50 plus 50 of long eyelashes. And we're done.